All right, so tonight we're going to start talking about one of the best chapters in the whole book, the neural tissue chapter. And we're going to learn about neurons in the nervous system. And we have two types of cells that we're going to talk about, both neurons, which are the main signaling cells of the body. These are the ones that are specialized for conduction and propagation of electrical signals. And then we have neuroglia, sometimes pronounced neuroglia. Sometimes the British say glia. But either way, it's neuroglia is a correct way to say it. And basically, these are the supporting cells. And you will see them throughout the nervous system, and they play a very important role. And there are many types of glial cells, and we'll encounter several of them as we further progress through the chapter. All right, so we've got the brain and central nervous system, which is our brain and spinal cord, which make up our central nervous system. And before we continue much further, I would like to reiterate a diagram that we drew at the very beginning of class when we talked about homeostatic regulation. And we made the analogy of the HVAC system, that is your air conditioning and heating. And we had out here a thermometer, which is a receptor, and it would send signals to a thermostat, which basically is our regulatory unit, our central regulatory unit. And that would regulate our temperature, and it would take information from the thermometer about what kind of environmental external factors we had. And then depending on what kind of information it received from this thermometer, which is our receptor, it would then issue commands to an effector, which in our case was our HVAC system. So basically our air conditioning or our heating unit or what have you. So this was our system, and we can liken this, you'll see this over and over again as we progress throughout the rest of the unit. So basically what we have is we have a central regulatory unit, which is very similar to our central nervous system, which is made up of the brain and the spinal cord. So this is our CNS, or central nervous system. And we can make the analogy that this is very similar to our thermostat in the example. So this is our CNS. And then on the brain, coming out from the brain and the spinal cord, we have what are called the peripheral nervous system, or nerves. Now we have 12 pairs of cranial nerves, which are attached to the brain and the brainstem. And then we have 33 pairs of spinal nerves that come out from the spinal cord. I'm not going to draw them all, but you get the idea. And these are what are going to bring information from the body, from the receptors in the body that are bringing information about the external environment to the central nervous system, and then be issuing commands from the central nervous system to the effectors, such as your skeletal muscles. So our effectors in our case, this would be our peripheral nervous system out here. This is our analogy, PNS. And our effectors would be things like skeletal muscle, and things like smooth muscle, glands, adipose tissue, and so forth. And so in our analogy here, we have receptors that are going to be bringing information about the external environment. And they're going to be bringing information to the central nervous system, which will then make decisions. We'll first collate that information and figure out what to do with it. And then it will issue commands to effectors that will make our body do things to react to our environment. All right, so we have the central nervous system and the peripheral nervous system, as I've just outlined on the board. And we can also subdivide these categories. So, for example, we know that the central nervous system is our central processing area. This is what's going to make our decisions for us. This is where all of our higher order functions occur. This is where consciousness, thought, this is where decision making occurs. And it's also, how we interact or decide to interact with our environment. All right, the peripheral nervous system is going to be everything outside the central nervous system, all the nervous tissue, all the receptors, and all the interfaces with the nervous tissue with their effectors. All right, So the peripheral nervous system, as we've said, is divided into 12 pairs of cranial nerves. I should say the nerves, and 33 pairs of spinal nerves. And as the name implies, the cranial nerves, each pair is attached to the brain somewhere, and the spinal nerves are attached to the spine. All right, so let's look a little bit at the peripheral nervous system, and we're going to look at what we call the afferent system. And the afferent system is the part that brings information to the central nervous system. So in our diagram here, that would be everything bringing information from receptors to the central nervous system. So this would be our afferent system. Then we have our efferent system, which brings information, or actually brings commands issued from the central nervous system to the effectors. So the way to think of it is the efferent system exits the central nervous system and relays commands to effectors. And in this way, we can react to things in our environment. So, for example, imagine you're walking down the street and you hear sirens suddenly and a police car comes screaming around the corner, and there you are in the middle of the road. What are you going to do? You're going to get out of the way, right? And the reason that you're able to do this is because you're receiving information in real time from the receptors, for example, your eyes, your ears, your senses. That information is being relayed to the central nervous system. Your central nervous system then processes that information, decides what to do with it, then issues commands to your skeletal muscles to move out of the way, right? All right. So, the receptors are the sensory parts that are going to be receiving the information from the external environment. So, for example, we've seen some receptors in class. We've seen, for example, the tactile corpuscles in our integument model, the lamellated corpuscles. These bring information about touch and pressure. We also have temperature sensations in our hands, pain, touch, temperature, pressure. All of these are generalized senses, and they all have receptors that are able to pick up that information. We also have what are called special senses that are located in the head, like your eyes, your ears, your taste, your olfaction, and your smell, and your sense of equilibrium, and that's your sense of being upright. That's what keeps you from falling over as you're walking down the street. So all of those are special senses, but in any case, all of them have receptors, and they are sensitive to a specific type of sensation, and they relay information about that to the central nervous system, which can then process that information and decide what to do with it and issue commands based on that. And that's what the effectors are. Those are the things being commanded by the central nervous system to do something. And we have several divisions of this. We have in the peripheral nervous system, we have what's called the somatic system. So I'll put P and S down here. So we have both the peripheral system, we have the somatic system, which controls skeletal muscles. And then we have the autonomic nervous system, which is not within our conscious control, and this is going to control things like smooth muscles, glands, adipose tissue, these kinds of things. So our somatic nervous system is going to be under our conscious control. So when we do something, the somatic nervous system, when we consciously decide to walk somewhere or write on the board or listen in class, this is part of our somatic nervous system as we're writing the notes that we're hearing. So we consciously control this, and this controls our skeletal muscles. So the effectors of the somatic nervous system are going to be skeletal muscle. The autonomic nervous system is going to have as its effectors things that are not under your control, such as smooth muscles, glands, adipose, and also I should put one other thing in here, cardiac muscle. So cardiac muscle. Because these are not things that are under your conscious control. Now within the autonomic nervous system, we have two divisions within the autonomic nervous system. We have the sympathetic division and the parasympathetic divisions. And these typically have opposite effects on the organ systems that they control. Most organ systems will have dual innervation from both of these. And one of them, the sympathetic nervous system, is what we know as the fight or flight nervous system, because it prepares you for conflict. The parasympathetic nervous system is known as the rest and digest, because what it does is it will basically divert energy away from your skeletal muscles, away from the things that you would need when you're highly active, and basically divert those resources, blood supply and so forth, to the digestive organs and to the other organ systems. So for example, the sympathetic nervous system, the fight or flight nervous system, is going to mobilize your resources. It's going to release adipose. It's going to release glycogen stores. It's going to release glucose. It's going to allow you to use your metabolic reserves to be able to do something that's going to increase your heart rate. It's going to increase the force of contraction on your heart so that you can fight whatever the enemy is or flee from it. It's also going to cause your pupils to dilate so you can see and take in more light, see things better. Whereas in the parasympathetic nervous system is going to do just the opposite. So imagine you're going to go out and run a 5K or a 10K, right? And you've done that, probably have experienced sort of the butterflies in your stomach before you run the race or give a presentation or a recital or something like that. And that's the sympathetic nervous system kicking in to prepare you for whatever kind of confrontation or scary event may be coming up. So this mobilizes your resources, it makes you more alert, it heightens your awareness. Now once the events are done, the scary events, now you can relax. So the parasympathetic kicks in, which is your rest and digest system, and basically it's going to do all the things that the sympathetic system sort of shut down. For example, digestion. You don't want to be digesting a big hamburger while you're running a 5K, right? You don't want to be thinking about urination or defecation while you're running a race or doing something else. So typically what happens is the sympathetic nervous system will divert blood flow to your skeletal muscles. It'll cause your heart to beat faster, contract faster, your blood pressure to increase, so that you'll have and mobilize these resources to be able to be used by the skeletal muscles to be able to do something. Your sweat glands will be activated, you'll sweat more. These kinds of things will happen, and you will also divert blood away from the digestive system, and you will basically make the smooth muscles of the detrusor, which is the bladder muscle, relax so it's not contracting, and you'll basically shut down all urination and defecation responses. Now, when you relax after your big event, this is when your rest and digest system kicks in, the parasympathetic, and basically what happens is you then divert blood supply back to your organs, your internal organs, digestive organs, so they can do their job. You'll start having contractions and peristalsis within the digestive system, along the urinary tract. Defecation and urination responses will kick back in. You'll basically decrease your sense of awareness. Your pupils will constrict as you tend to focus more in the general sphere in your immediate surroundings rather than out in the larger scope of things. Now what's interesting is most organ systems are innervated by both, and they have an opposite effect on each other. So to take the heart, for example, as we know, the sympathetic nervous system is going to speed it up. So if you leave the heart to beat on its own devices, it typically sets its own pace, typically between 60 and 100 beats per minute, or typically 80 to 100 beats per minute. But if you stimulate it with the sympathetic nervous system, your heart will increase, your heart rate will increase, so that you can meet the needs of the threat. Now in the parasympathetic, that's going to slow your heart rate down. And typically, when we are at rest, the parasympathetic system is the one that dominates. So that usually brings our heart rate down to about 60 beats per minute. So most people have a heart rate somewhere between 60 and 70 beats per minute because the parasympathetic nervous system is maintaining control over it. So as I say, these two systems work in opposition to one another, and most organ systems have a dual innervation where their equilibrium and balance is maintained by a continuous spectrum along these two systems with a dual innervation, so that whatever is needed at that particular moment, that's the nervous system, or that part of the autonomic nervous system that predominates. There are two systems that come to mind immediately: the smooth muscles of the vasculature, that is the circulatory system, and the sweat glands that are only under the control of the sympathetic nervous system. And basically what happens there is the sympathetic nervous system just adjusts its tone, either higher or lower, to control the responses of those two systems. All right, so this is basically what we just went over. The somatic nervous system controls your skeletal muscles. That is under your conscious control. The autonomic nervous system controls your smooth muscles, glands, adipose tissue, cardiac muscle. We have our divisions again. We have our sympathetic division. Here's our autonomic. We have our sympathetic and parasympathetic divisions. This is a nice little chart that you have in your book. And so we have so far concentrated on the efferent division of the peripheral nervous system. All right, and we also have our afferent division that we'll talk about in just a second. So we've got our special sensory receptors, which are all located in the head, like your eyes, ears, your olfaction, your taste, and your sense of balance or equilibrium. We also have our visceral sensory receptors, which are inside of your digestive organs, organs inside your body, all throughout your body. So these are the receptors that are bringing information from your viscera. And then we have our somatic sensory receptors, which are all over the skin and basically give us information about our external environment. So this will tell us about our external environment, our general senses, plus we have another type called proprioceptors, which tell us where our muscles are in space, and that helps us coordinate movements. So for example, with this little object here, if I want to grab that, I know pretty much where it is, and I can turn around and grab it without ever having to see it because I know where my muscles are in space. Now for someone who has damage to the peripheral nervous system or has damage to his proprioceptors, these movements are very difficult to coordinate even when they can see the object because they have no feedback from their muscles as to where they are in space. So these type of receptors that are part of the somatic sensory system are located in muscles and within joint capsules, and they tell you about where your joints and muscles are in space. All right, so neurons, these are the main cell of the nervous system. And so what I'm going to do very quickly here is go over the anatomy of a neuron very quickly.